Hello friends, welcome to next part in blog series on developing an OCR Vision AI. As we saw in previous blog, this is the chatbot Vision AI application we are going to build. Our end product is going to look exactly like this application. In our previous post, we discussed a high-level solution architecture diagram. We covered a lot of theory how our app system application is going to look like from architecture perspective. As we discussed that we will build this entire application one step at a time. So in this blog today, we are going to focus on one such component, that is build a file drop functionality. We already covered most of the architecture details in last post. So if you are finding this blog for the first time, please take some time to review earlier post to get some background. Now here is X link where you can find this blog. If you go to my profile and browse to X highlights, you will find this video blog there. Similarly, if you browse to my YouTube channel, you will see the same video. And if you are a pro developer and you just want to see the code, you can go to my GitHub repository directly. And while you are there, I request you to please follow my X account, which goes by the handle ashuklax, GitHub handle amitxshukla, and subscribe to my YouTube channel at amit.shukla. So in today's section, we are going to only focus on building one specific component, that is build a functionality which addresses one functionality, which is file drop. So let's get started. Writing cron job. As I stated earlier, we will not worry about other parts of the application for now. And in this section, we are going to write code to address one specific problem. Once a file is dropped, it is going to trigger some local AI logic or a built-in process, which reads the data and then write the data to a SQL and a vector database. Now, since entire logic and other part of this application are not ready yet, and we are just getting started, so let's first work on this one specific problem. So write the code which does something as soon as a file is dropped to a shared drive. Once this basic component, which is the starting point of our application, is ready, then we are going to write further part in next blocks. Let's write code to initiate a cron job. Please see, we'll get this done in 3 simple steps. Step number 1, create the Python script which does some task. So for example, creates a timestamp text file. Step number 2, create a shell script to monitor the drive. So for example, continuously monitor the directory for new files and call the Python script as soon as the file is dropped there. Step number 3, finally we are going to set up the cron job, which runs these shell scripts every minute to automate this whole process. In this step, we'll write a script that creates a new file when executed. Let's keep it simple for now and focus on the basics. Because we are not diving into the GenAI code yet, we'll not write code to try to read the content of this file. We'll just focus on simply, let's create a new file as soon as this script is called. So let's start with importing the datetime package by writing import datetime. Next, we'll define a function called create timestamp file. Inside this function, we'll get the current date time using datetime.now. Now, we are going to format this timestamp as YMDHMS, which stands for year, month, date, followed by hours, minutes, and seconds. And we are going to use it as the file name. Then we'll open this file in a write mode and write the timestamp inside it. So that's exactly what this entire function does. Finally, we'll call this function within a main block. This ensures the functions runs only when the script is executed directly from the command line. So this is the why we use the syntax if __ name __, which is also called dunder method. So if dunder name is equals to main. Now to achieve this, when this script is called, it will create a new file with the current timestamp as its file name, and at the same time is going to write that timestamp inside it. Alright, just to recap one more time what we did. Number 1, we imported the datetime package. Number 2, we defined a function called create timestamp file. Now we got the current date and time using datetime.now function, and we formatted the timestamp as YMDHMS and use it as the file name. Now we are going to open this file in a write mode and write the timestamp inside that text file as a file content. Number 3, we call this function in a main block using if name equals to main. Now to ensure the function runs only when the script is executed directly. So this process creates a new file named with the current timestamps and write the timestamp inside it. In this step number 2, we are going to write a bash script, which simply execute the Python script we created in step number 1. Now because this is a bash script, this will be is going to execute the Python command like a script. Let's go break it down, this bash script, line by line. So in number 1, you will see shebang exclamation bin bash. So what this is called shebang? It tells the system that this script should be run using the bash Linux shell. Number 2, wash directory equals to path to your directory. So here in this line, we are defining a variable called washed_dir. Now what this variable does, it assigns the path of the directory which you want to monitor. Number 3, last_file equals to blank. So simply here we are initializing a variable last_file as an empty string. It will be used to keep track of the most recently processed file, because in real world we are designing this application to handle thousands of documents. It's very important to keep track of how many files are processed. Finally, while true, what we're going to do, this starts an infinite loop. So this script will keep running the commands inside this loop indefinitely. Next, the do keyword. This marks the beginning of the commands that will be executed in each iteration of the loop. So when you say new file equals to ls-t wash directory pipe with head -n when. So what this line does, this commands list the files in a wash directory, wash_dir directory, and it's going to sort them by modification time, and that's what -t does. And then you select the most recent file, which is head -n and number 1, that's the most recent file, and the result is going to be stored into the new _file variable. And then finally, we compare this new file variable to the last file variables. Again, this script may look a little complex. It's very simple when you write it down. So if new file is equals to last file, then skip. Otherwise, it checks for the most recent file. And if it's different from the last process file, then it's going to create a new file. So last file equals to new file. And if the new file is different, then the line updates the last file to the new file. Finally, what we do, we run the file processor Python script what we created. So we use the command say Python 3 and part 2 where the file processor.python script you have created. So what simply this is going to run the Python script which we created in step number 1, which was like file_processor.py file. Now here you should make sure that you replace the path to all those files. You know, wherever you have kept your Python file, please make sure that you replace that file path to this variable here. All right. fi keyword marks the end of the if statement. Sleep 10, what it means that this is going to pause this script for 10 seconds before the next iteration of the loop. And finally, the done keyword, this marks the end of the while loop. So in summary, what this script is doing, it continuously monitoring a directory for the new files. So as soon as the new file is dropped into that particular directory, it's going to execute the file processor.py file. That was the file that we created in step number 1. In step number 1, whatever the Python script says is going to execute that Python scripts as soon as a new file is detected. Okay, and then what it's going to do is simply is going to sleep for another 10 seconds and before checking it again. Now, and finally, in this step, we are going to create the cron job. This cron job simply execute the bash script what we created in step number 2, and is going to execute that bash script every minute. So let's go break this down, these commands step by step. So first you will see cron tab -e. This commands open the cron table, which is short for cron tab. For editing, so -e means you're opening that cron table for editing. Now, what is a cron? Cron is actually a time-based job scheduler in Unix-like operating systems. And -e, you're opening that cron table for editing. And here, once you edit that, then simply you can add the second command, which is star 5 times star and followed by the shell script, the bash script what we have created. Now this line is a cron job entry. So let's break it down. So 5 asterisks, what it means that the first asterisk is for the minutes, second is for hours, third is for days, days of the month, which goes from 1 to 31. Fourth star, as you can get, is for the month, which goes from 1 to 12. And the fifth is days of the week. So from 0 to 7, which starts from Sunday all the way to all the Saturday. Okay. Now, since all these fields are asterisk, this cron job will run every minute of every hour of every day. And if you find it too much, please, you can go back and change it. But right now, because there are 5 stars, so that means that it's going to run the job every minute of every hour of every single day. Okay. Now, There's one more thing. You should also replace that path to monitor drive.sh. Now you should replace this path to the bash script what you have created in previous step. Okay. So in summary, what we did, this combining all these steps, we are going to schedule the monitor underscore drive bash script what we have created to run every minute, ensuring continuous monitoring or execution of the task defined in this script. That's all I wanted to achieve in this video today. So as you saw in this video, we created a very simple cron table job which monitors the activity on a drive. So as soon as a file is dropped, it does something. So this is a very basic functionality what we have created. So in next series of the blocks, as we dive into more and more deeper and try to build this more sophisticated components, we are going to make use of, we'll come back and make use of this functionality what we have created, and we are going to enhance it further. So that's all I wanted to achieve in this video today. I hope you like it. If you have any questions, please feel free to comment on my GitHub repository. If you have any issues, open an issue log and I'll be happy to help you out. Thank you very much. Stay tuned.